Good evening everyone. I am Riyat Iqbal. I am doing PhD under the supervision of Professor Sudeep Mishra at IIT Kharagpur. Today we will discuss the topics of week 8 and after that we will discuss some questions. So last week we discussed about SDN, that is software defined networking. So in case of your mobile network, in order to you, there are some problems. In case of your traditional mobile network, there are some problems. For example, it is difficult to scale your traditional mobile network because uh, static over provision networks are inflexible to manage the mobile traffic with high demand. Second one is difficult to manage because there are millions of devices and all the devices have different configurations, belongs to different vendors, so it becomes difficult for to manage such kind of large network. The third problem is inflexible, so it requires too much time to introduce new services as the hardware architecture in case of your traditional mobile network is inflexible. Next one is cost expensive, so both capital expenditure and operational expenditure is high in case of your traditional mobile network. So in order to resolve this problem, SDN, that is software defined networking, can be used in your mobile networks. So basically flow table paradigm of SDN should be used, so well suited for end-to-end communication over multiple technologies such as your Wi-Fi, 3G, 4G, etc. Second, the second problem of your mobile traditional mobile network is that it is difficult to manage. So if you are going to use SDN, it provide logical centralized control with the help of which the management will become easy. So particularly it is useful for efficient base station coordination for addressing an intercell interference. The third one is path management. So in case of your so if you are going to use SDN in case of your mobile network, the path management will become easy because data can be routed based on the service requirement without depending upon the co-routing policies. The next one is network virtualization. So your SDN will provide network virtualizations because basically the physical resources are not at the same point where your network services are, right? So it helps in providing seamless connectivity and service differentiation among the users. Then the key benefits of using SDN for mobile networking. First one is centralized control of devices manufactured by multiple vendors. High rate of integration of new services. So basically if you are going to use SDN in case of your mobile networking, so if you are going to introduce some new service, you only need to make changes at the controller. You don't need to make changes at the complete network. So it is easy to deploy or integrate new services if you are using SDN in case of your mobile networking. Third one is abstracted network control and management. Now the challenges. So if you are going to use SDN in your mobile networking, then there are some challenges. So first one is journal OpenFlow does not support wireless network. Basically the OpenFlow protocol, which was introduced for your static network, cannot be used for your wireless network because that does not support wireless network. Second is there is a need of modified OpenFlow protocol which can be used in your wireless network. So we need to propose that kind of solution, or we need to make some modification to OpenFlow so that mobile network can be handled. Next is typically users are mobile in nature, due to which the network is highly dynamic. Next challenge is frequent changes in rule placement is also required because in case of your mobile network, the devices are moving continuously, due to which the data which is required by the devices will also get changed. So there will be frequent changes in the rule placement as well. The next one is presence of heterogeneous devices in the network. So there is a problem of interoperability also. Then next challenge is how to support such heterogeneous devices in a single platform, because in case of your SDN there is a single controller. So in order to manage all the devices, it becomes difficult. Screen is not visible. Is it visible now? Is my screen visible now? Can anyone please confirm? So the solutions or the approaches which can be used in order to resolve these challenges are ODIN, that is ODIN. Then next one is UBflow. The next one is MobiFlow. Basically, these are the research works which are done by various researchers in order to resolve these challenges. So maybe one of the approach can be used to resolve either one or two challenges. So basically these approaches are not used to overcome all the challenges, but these approaches target either one, two or three challenges of the the first approach is ODIN. So in case of ODIN, an agent is placed at the access point to communicate with the controller. So basically in case of ODIN, there are two components. First one is ODIN agent and second one is ODIN master. So ODIN agent is placed at the physical devices, that is the access points, and ODIN master is placed at the controller. So the communication between the access point and controllers take place with the help of these two components, that is ODIN master and ODIN agent. Now this figure is showing that how the communication take place. So basically if a data frame is received, then the client will check whether light virtual access point is assigned to that particular frame or not. If it is assigned, then it will drop the frame. If it is not assigned, then it will drop the frame, otherwise it will forward up. However, if it is the management frame, it will again check if light virtual AP is assigned. Okay, I'm sharing again. I have shared the link in the chat box. You can check whether you are able to access that or not. Yeah. So if the frame is management frame, it will check if the lightweight virtual access point is assigned. If it is not assigned, then the client will assign a lightweight virtual access point to that particular management frame. Um, Otherwise, if it is already assigned, then it will process that particular management frame and respond accordingly. The next approach is UBflow. So UBflow was introduced in order to manage the mobility in case of your software defined IoT devices and flow scheduling, that how the data will be transferred. So it will basically focus upon network partitioning, network matching, load balancing, uh, and in case of mobility management, it will focused upon the scalable control of the APs and the fault tolerance. Screen is not visible yet. Is it visible now? confirm if you are able to see my screen or not. Write in chat box. Not yet. Okay, I'll join again. I think there is some issue at my end. I have already shared it. Please check whether are you able to access the link or not. Okay, thank you. And is my screen visible now? Okay, thank you. Yeah, so next approach is MoviFlow. So in case of MoviFlow, proactive rule placement depending upon the user movement in the network is decided. So basically that okay. Yeah, so in case of MoviFlow, the location of the end users at time t+1 is predicted on the basis of the location on the basis of the present location of the end user, and depending upon the location of the end users, the flow rules are placed at the access points. So this is the MoviFlow approach. So location prediction is done by using order K Markov predictor, and flow rule placement is done using linear programming. If you want to get more idea about these approaches, these are the research paper. You can go through these research paper how exactly they are working. Next is rule placement at backbone network. So existing rule placement schemes for wired network can be used in your mobile networks as well. Load balancing is an important issue due to the dynamic nature of the IoT network, and dynamic resource allocation can also be integrated. So in case of your mobile network, these are the three main research areas which can be focused upon. Yeah. Now next one is data centric networking. So in case of data centric networking, more focus is on the data rather than on the application. So in data centric networking, there are two types of flow. First one is the mice flow and second one is your elephant flow. Mice flow is the flow of data in very small chunks. However, in case of elephant flow, the data is sent in bigger chunks. So basically in mice flow, wildcard rules can be placed to deal with mice flow. However, exact match rules are useful for your elephant flow. So in case of your data centric networking, you first need to classify which kind of flow is there before inserting the flow rules at the switches to adequately forward them into the network. Now anomaly detections in IoT network. So it monitors the network through open flow to detect any kind of anomaly in the network. This can be done by monitoring each flow in the network. We can also collect the port statistics of the switch in order to detect the anomaly. And if there is any anomaly, it may generate large number of packets in the network, and it can be detected by monitoring the flows. Then experimenting with wireless network. So mininet Wi-Fi can be used. So if you want to experiment with wireless network, basically if you want to use SDN in your wireless network, then you can use mininet Wi-Fi. The second method can be ONOS. So here it can be used to place the controllers. Now the next topic is cloud computing. So cloud computing is a model for enabling convenient on-demand network access to the shared pool of configurable computing resources. So resources can be your network infrastructure, server, storage, applications. So this definition is given by NIST. So initially there was cluster computing. So basically in case of cluster computing, there were various homogeneous nodes which work together in order to perform some computational task. Then evolution is made and grid computing was introduced. In case of grid computing, instead of homogeneous computing node, there are heterogeneous computing node which are distributed over the wide area network, and these heterogeneous computing nodes are used to perform the large tasks. The third one is utility computing. In case of utility computing, packaged resources are available for computing and storage. Then after utility computing, cloud computing was introduced, and in case of cloud computing, shared pool of configurable computing resources are there. So these resources are ubiquitously present, and these resources are dynamic. So depending upon the need of the user, you can access the resources, and whatever amount you want, you only need to pay for that amount of resources. So it's not like that at this point of moment you want 10 resources, right, and at the other point of moment you want 5 resources. So you can dynamically make changes according depending upon your need, and you only have to pay uh, whatever amount of resources you have used. Yeah. So these are the properties. So it can be envisioned as a step on from utility computing. It provides high level generalization of computation and storage model. It can be rapidly allocated and released with low management efforts. It has some essential characteristics, service models and deployment models, which we will discuss in this session. It provides on-demand services to the end user that can be accessed from any place at any time. Now this is the evolution. Basically in 1950 time-shared mainframe computers are there. Then in 1969 ARPANET was introduced. Then in 1970 virtual machines were introduced by IBM. Then in 1990 expansion of the internet was there. Then 1996 and 1997 cloud computing was introduced. Then in 1999 Salesforce.com was introduced. Then in 2002 AWS services, that is Amazon Web Services, was introduced. Then in 2006 Amazon EC2 was introduced, and in 2008 Microsoft Azure and Google App Engine was introduced. Now the business advantages of cloud computing. So first one is nearly zero cost for upfront infrastructure investment. Second one is real-time infrastructure availability. So whenever you want to use the infrastructure, at that time you can fetch from the cloud. Next one is more efficient resource utilization, because depending upon your need you can use the resources. Usage based costing, so whatever you are using you have to pay for that. Reduce time to market, because you don't have to go to market to purchase any kind of infrastructure to set up your business. You can directly use the resources which are available at the cloud and do whatever your application is. Now the journal characteristic of cloud computing. First one is improved agility in resource provisioning. Second is ubiquitous, so it is independent of the device and location. Then multi-tenancy. Multi-tenancy means the resources which are there, it does not belong to any particular user, so there is a sharing of resources and cost across the large pool of user. Then dynamic load balancing is there. Then highly reliable and scalable, low cost and low maintenance, improved security and access control. Now NIST visual model of cloud computing. So basically this NIST has provided this model of cloud computing, which consists of essential characteristic of cloud computing, then service models and deployment model. So according to this NIST visual model, the essential characteristic of cloud computing are: first one is broad network access, second is rapid elasticity, then measured services, then on-demand self-service and resource pooling. So broad network access means, so anywhere from the network you can access the resources. Second is rapid elasticity. Rapid elasticity means whatever your need is, depending upon that you can access the network. So basically it's elastic, so depending upon your need you can either increase or decrease the number of resources you want. Then measured services, so whatever services you are using, accordingly you have to pay for that. Then on demand self service, so it is okay, from the name you can easily get that whatever you want you have to fetch from cloud on self and use that. Then resource pooling, so basically in case of cloud it's not like that there is only one service provider which is providing services. There are various service providers which are providing various kind of resources, infrastructure, but for the end user it seems that there is one large pool of resources from where you can access those. Then the service models. So according to NIST, there are three service model. First one is your software as a service, second one is your platform as a service, and third one is your infrastructure as a service. We will discuss all these in the upcoming slides. And the deployment models are public, private, hybrid, community. So these are the essential characteristics I have already discussed. First one is broad network access. It means that cloud resources should be available over the network. It should support standard mechanism for information retrieval using traditional interfaces. Supported clients can be either heterogeneous thin clients or thick clients, depending upon the application. And second one is rapid elasticity. Rapid elasticity means cloud resource allocation should be rapid, elastic, and automatic. Dynamic allocation and release facility for scale out and scale in should be there. Consumer should feel that there are infinite number of resources which are available. Then facility for adding or removing the number of resources should be there. Third is on demand self service. So provide server time and network storage to the user automatically. This facility should be available as a self service to the end user. The next one is resource pooling. Then it means automatically pool the whole available resources, serves multiple end user using multi-tenant model. Resources should be allocated according to the user's demand. Then measured services. Resource usage should be recorded and monitored. Facility to dynamically control and optimize the resource usage. This facility should be transparent between the service provider and consumer. Then components of the cloud computing. So first component is client, that is end user. So the client can be thick, thin, or mobile. Thick clients means they have enough resources, thin clients means they don't have enough resources, and mobile means they can move from one place to another. Then services. So services can be either products or solutions. So for example, your identity mapping, searching, so these kind of services can be there. Then application, web apps, software as a service. Then platform is one of the component. Then storage. After that, infrastructure. So these are the service model which we have already discussed. Now service model. Okay, this is not service model. Yeah, this deployment model of cloud computing. Here it should be deployment model. So basically these are different kind of deployment models. First one is public cloud, second is private cloud, then hybrid cloud. Apart from these three which are main, there are other also, for example community cloud, distributed cloud, multi cloud, and inter cloud. Public cloud means so anyone in the network can access the services which are provided by the public cloud. It is owned by a particular organization. Yeah. So in case of private cloud, the cloud is organized by a particular organization, and hybrid cloud is the combination of these two, that is public cloud and private cloud. Apart from these, one is community cloud. Community cloud means it is organized by a particular kind of community, for example doctors or engineers. For example, in case of healthcare, there is a cloud which is maintained by different kind of different hospitals, right, in order to exchange information. So that can be your community cloud. Then distributed cloud. Distributed cloud means the services which are there are distributed among various servers. Then multi cloud. Multi cloud means that multiple service providers are going to provide you the services. And intercloud means different clouds, there are different clouds which are exchanging services, which are exchanging data and interacting with each other. Nowadays there is one concept which is called sky computing. So sky computing means basically the intercommunication between your different kind of clouds which are there. Now first one is public cloud. So cloud setup for the use of any person or industry. Typically it is owned by an organization who offers the cloud services. Example of public.
मैम नेटवर्क इश्यू.
Okay.
आपकी आवाज ग्लिच होके आ रही है, कट 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 करके।
Okay, wait, I'll
इसमें वॉइस ब्रेक की।
wait. So if there is network issue, because I don't know why it is there, I can directly go to the questions also, because these things are already there in the lectures which are there in NPTEL website. Is it fine?
ओके मैम, ओके।
Now voice is coming clearly, or
ओके मैम, क्लियर।
okay. Hello, is my screen visible now? Can anyone confirm whether my voice is clear or screen is visible? Hello, am I audible now? Is my voice clear?
Yes, ma'am, you are audible.
Am I
यस मैम, ऑडिबल।
okay? So you
यस।
are able to hear me clearly, properly, right? No network problem. Okay. Okay, so actually today I have some network issues. I am directly going to questions part, because these things are already there in the NPTEL lectures, right? Yeah. So first question is, which of the following is an issue relevant for communication in wireless sensor network? Options are diffusion, interference, diffraction, inheritance. Anyone?
It's option B, interference.
Okay. Anyone else? Yeah, correct option is interference. Next question is, in a cloud computing paradigm, the user does not have availability to on demand services. Is this statement true or false?
It's option B, false.
Right, because in case of cloud computing, the user have uh, access to on demand services. So this statement is false. Next question is, which among the following can be rented as a utility service by a client remotely in cloud computing? Options are hardware, software, memory and storage, all of these.
All of this.
All of these. Okay, anyone else?
D.
D, right. All of these is correct because in case of cloud computing, you can rent either hardware, software, memory, storage, anything. Next question is, when you are accessing Google Docs or Microsoft Word online for accessing the feature of a document writing software from your own browser without specifically installing them, which cloud service model you are using? Options are software as a service, platform as a service, infrastructure as a service, then database as a service.
It's option A, software
Software
as
as
a
a
service.
service.
Right, software as a service, because these are the softwares which you are using for writing. So correct option is software as a service. Next question is, in cloud computing service model, what does XaaS stand for? Options are security as a service, connectivity as a service, network as a service, anything as a service.
Anything as a service.
Anyone
Option
else?
B, anything as a service.
Right. XaaS stands for anything as a service. Next question is, Microsoft Azure is an example of blank service provider. Options are SDN, cloud computing, batch computing, operating system.
Cloud
Cloud
computing.
computing.
Right. It is cloud computing service provider. Next question is, no virtualization is used in cloud service provisioning. True or false?
Option
False.
B, false.
False. Okay, anyone else? Yeah, this statement is false because virtualization is there in case of your cloud service provisioning. Next question is, what does DBaaS stand for in cloud computing service model? Options are disk as a service, database as a service, distribution as a service, data buffering as a service.
It's option B, database as a service.
Right, it's database as a service. Next question is, suppose a hospital that deals with sensitive patient data wants to have cloud support for all of its computer, but it wants to set up its own secure cloud infrastructure. This let me complete first. This is an example of which of the following model? Public cloud, hybrid cloud, private cloud, none of these.
It's option C, private cloud.
Private cloud. Okay, anyone else?
Option C, private cloud.
Right, because in this case only a particular hospital wants to store its data. So it is owned by a particular organization, so it is private cloud, that is C. Next question is, what does CIA in cloud data security stand for? Option A is confidentiality, integrity, availability. B is confidentiality, inheritance, automation. C is congestion, integrity, authentication. D is criticality, integrity, accountability.
Option A.
Option A.
Option A. Okay, anyone else? Yeah, it's option A. C stands for confidentiality, I integrity, and A availability. Next question is, in virtualization, a hypervisor is responsible for orchestration between the underlying physical hardware and the virtual machines being installed. True or false?
True.
True. Okay, anyone else?
True.
True. Yes, this statement is true. So basically, a hypervisor provides the necessary orchestration between virtual machines and host computer. Next question is, for a secure cloud deployment, which among the following are needed to be considered? Options are network level security, host level security, application level security, all of these.
Option D, all of this.
Anyone else? Right, it's option D. Next question is, cloud sim is a type of, options are cloud network, cloud simulator, cloud enhancement, cloud model.
It's a cloud simulator. Option B.
Right, so option B is correct. Cloud sim is a cloud simulator. Next question is, before cloud computing provisioning, the client is provided with the details of various warranties in which of the following document? Options are service level authentication, service level agreement, software level agreement, software level authentication.
It's option B, service level agreement.
Right, it's option B, that is service level or agreement. So in service level agreement, various kinds of warranties, billing conditions, all these things are mentioned. Next question is, Amazon Web Services is an example of, options are open source cloud, deployment cloud, commercial cloud, not a cloud platform.
Commercial cloud.
Option C, commercial cloud.
Anyone else? Yeah, it's a commercial cloud. Next question is, the process of abstracting physical network hardware and resources from the network services and use cases are known as, options are network splitting, network virtualization, network scaling, none of these.
Network virtualization.
Option B, network virtualization.
Okay, anyone else? Right, it's network virtualization. So it is a process by which various network services are abstracted from their underlying physical hardware for smooth management. Next question is, ODIN is one of the proposed solution towards software defined WSN and mobility management. As per the architecture of ODIN, which component of ODIN is placed on the top of the controller? Options are ODIN master, ODIN agent, ODIN both master and agent, neither master and agent.
It's option A, ODIN master.
Anyone else?
Master.
Right,
ODIN.
master is placed at the controller and agent is placed at the access points. Next question is, shared pool of resources with easy configurability are important aspects of cloud computing. True or false?
Option A, true.
Yes, this statement is true. Next question is, in cloud computing, the user have specific knowledge about the exact physical location of the computing hardware with respect to cloud services. True or false?
Option B, false.
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 Right, this statement is false. Next question is, suppose there are two organizations, A and B, both of which provide cloud services. Any user can access the cloud of A free of cost, whereas only employees of organization B can access the cloud of B. Also, organization B has set up its cloud for only its own needs. With respect to type of cloud infrastructure provided by A and B, which among the following is true? A is private cloud, B is public cloud. Option B is A is public, B is private, C is A is public, B is public, D both A and B are private.
Public and private.
It's option B, A, public and B, private.
Okay, A public and B private. Anyone else? Right, it's option B. A is public and B is private. Next question is, which among the following can be considered as potential service model for cloud computing? Options are software as a service, database as a service, platform as a service, all of these.
All of these, option B.
Anyone else? Right, all of these is correct. Next question is, which of the following component can be considered as optional for sensor node? Options are sensing unit, transceiver, location finding unit, none of these. This belongs to, I guess, I don't know from which week, but yeah, we have covered this topic.
C, sir. Location
Option
finding
C.
unit.
Yeah, location finding unit is not.
Option C, location finding unit is optional.
Location finding unit is optional in sensor node. Next question is, you have bought a spreadsheet processing software in the form of CD-ROM, which you would need to install yourself on your computer to run and then manage. Is it an example of software as a service in cloud computing? Yes or no?
Option B, no.
No.
No, right. Because in this case you have purchased and you are going to install in your computer. However, if it, in case of cloud computing, you don't need to install anything in your computer. Next one is, suppose two person A and B both wish to access a particular software as a service feature from a cloud service provider through their respective personal computer. Both of them log into the cloud at the same time. Then which among the following is true? Option A is neither A nor B will able to access the service. B is A will able to access but B is not. C is B will able to access the service but not A. D is both A and B will be able to access the service.
Option D, both A and B will able to access the service.
Right, because in cloud computing there is a concept of resource sharing. Right, so all the resources are shared, the load is balanced, and with the help of which all the end users can access the services. Next question is, which among the following security paradigm is concerned with securing the in-transit data between the user and the cloud through internet? Options are network level security, host level security, application level security, none of these.
So option A,
Network level.
security.
Anyone else?
Network level security.
Right, it's network level security. Next question is, cloud security ensures question is cloud security ensure that blank user can access their data after proper blank. Choose which among the following should be correct order of words to be filled in the blank. Option A is legitimate authentication, B is illegitimate authentication, C is malicious inaction, D is malicious attack.
It's option A, legitimate authentication.
Yeah, option A is correct. So basically, cloud security ensure that only legitimate user can access their data after proper authentication. Next question is which among the following should be protected with proper access control in cloud computing? Options are database access, server access, virtual resource access, all of these.
It's option D, all of this.
Anyone else?
All of these.
Right, all of these is correct. Next question is before launching your cloud service as a product to customer, it is always a good idea to test your cloud application on a cloud simulator first in the pre-deployment phase. True or false?
It's option A, true.
Right, it's true. Next question is with respect to virtualization in cloud computing, which among the following can be considered as suitable virtualization paradigm? Options are storage virtualization, hardware virtualization, application virtualization, all of these.
All of these.
All of these. Anyone else?
Option D, all of this.
Right, all of these is correct. Next question is along with accounting, which among the following is an essential component of cloud service management? Options are virtualization, billing, deployment, none of these.
It's option D, billing.
Billing. Okay, anyone else?
Okay.
Option B. Right, it's option B, billing. Next question is which among the following are core challenges of traditional mobile network? Options are scalability, flexibility, manageability, all of the given.
Option D, all of the given.
Okay, anyone else?
Option D, all of the given.
Right. Next question is network virtualization enables blank of the physical resources. Options are movement, abstraction, removal, creation.
It's option D, abstraction.
Anyone else?
Abstraction.
Right, it's abstraction. Next question is in comparison to software defined networks, traditional networks are cost expensive with respect to which of the following? Both capex and opex, and that is capital expenditure and operational expenditure. B is capex but not opex. C is opex but not capex. D is neither capex nor opex.
It's option A, both capex and opex.
Anyone else? Right, it's option A. So basically, in comparison to software defined network, your traditional networks are uh, cost expensive in terms of both capital expenditure and operational expenditure. Next question is journal open flow support both wireless and wired connection. Is this statement true or false?
It's option B, false.
Right, you have to make some modification in your journal open flow so that it can handle your wireless connections as well. Next question is journal open next question is with respect to software defined center network, and that is SDDCN, blank can be wildcard and blank can use exact match rules. A is mice flow, elephant flows, B is elephant flow, mice flow, C is mice flow, traditional flow, D is traditional flow, elephant flow.
It's option A. Elephant Flow uses exact match rules.
Okay, elephant flows use exact match rule and mice flow use wildcard. Right, option A is correct. Next question is, in cloud computing model, which among the following are characteristic of computing resources? Options are on demand, shared, configurable, all of these.
It's option D. All of these.
Anyone else?
All of these.
Right, all of these is correct. Next question is, IaaS, PaaS and SaaS are example of what type of cloud models? Options are cloud deployment model, cloud service model, cloud access model, cloud virtualization model.
It's option B. Cloud service model.
Anyone else?
Cloud service model.
Right, these are cloud service models. Next question is, an organization A wants to deploy a cloud infrastructure whereby it wants to push majority of data to cloud whose server can be situated anywhere within the globe, but it wants certain private data to be pushed only to a cloud server that are present on premise and accessible by only authenticated members of the organization. In this context, which among the following deployment model should be used? Options are private cloud, public cloud, hybrid cloud, any of these.
It's option A. Private cloud.
Option C, hybrid cloud.
Anyone else?
It's option C. Hybrid cloud.
Right, it's option C because it wants to store its data at anywhere in the globe also. So for that it can use public cloud and some data near to its premise. So for that it can use private cloud. So that organization should use hybrid cloud. Next question is, which of the following type of client require constant communication connection with cloud server? Options are thin client, thick client, both thin and thick, none of these.
Option A, thin client.
Option A, thin client. Anyone else? Right, option A is correct because in case of thin clients, they don't have enough resources, so they require constant communication or connection with cloud server so that it can access the resources from the cloud service server. Next question is, fill in the blank. Typically, cloud computing have blank components. Options are 4, 5, 6, 7. How many? Repeat, please.
6.
6. Okay, anyone else? Yeah, option C is correct. That is 6. Next question is, okay, this is repeated
What are the
question.
6 components?
Yeah, we have discussed, right? So end users, then after that there are services, then infrastructure. In one slide there are various 6 components, so you can list down from there. Then database.
Okay.
Next question is, in software as a service model of cloud computing, which of the following act as thin client? Options are cloud gateway, web monitor, web browser, local firewall.
Web browser.
Anyone else? Yeah, correct option is web browser. Next question is, data in blank and data at blank are two important aspects of data security. Options are past, comma present. Option B is time, comma place. C is transit, comma rest. None of these.
Option C.
Transit, comma rest. Okay.
Option C, transit.
Right,
Option C.
right. Option C is correct. Next question is, which among the following is a metric for service level agreement in cloud computing? Options are availability, portability, response time, all of these.
All of this.
Anyone else? Yeah, it is all of these. Next question is, which of the following cloud computing model does AWS EC2 belongs to? First one is infrastructure as service, platform as a service, software as a service, none of these.
Option
Infrastructure
A.
as a
So
service.
option A, infrastructure as a service.
Right, option A is correct. Yeah, so these were the questions. So if my voice is clear now, I can go through the topics. So is my voice clear, or should I stop the session here?
My voice is clear.
Okay.
We can start the session.
Yeah. So we were at components. Components of cloud computing. So these are the 6 components. First one is client, then services, application, platform, storage, and infrastructure. Yeah, after that, the deployment models of cloud computing. So first one is public cloud, then private cloud, hybrid cloud. We have discussed this, right? I guess we were here. Yeah, so first one is public cloud. So public cloud, in case of public cloud, cloud setup for the use of any person or industry. Typically it is owned by an organization who offers the cloud service. The example of public cloud are Amazon Web Services, Google Compute Engine, Microsoft Azure. Then it is easy to set up at low cost as provider covers the hardware, application and bandwidth cost. Scalability to meet needs, pay-per-use ensure that from user perspective no resources are wasted. Then after that, uh, private cloud. So cloud setup function only for single organization. Typically it is managed by organization itself or third party. So the advantages of private cloud are total control over the system and data is there, then minimum security concerns are there, and then the disadvantage of private cloud is that it requires regular maintenance. After that, the third type of cloud is hybrid cloud. In case of hybrid cloud, the cloud is set up or constructed by 2 or more unique cloud setup, that is private, community or public. It is pooled together by standardized tools, support data and application portability. For example, facility for load balancing between the clouds, provide multiple deployment models. So in case of hybrid cloud setup constructed by two or more unique cloud setup. For example, it can be either public or private or community, so pulled together by various standardized tools. It support data and application portability and provide multiple deployment models. So now this table is showing the difference between the public cloud and private cloud. So in case of
Ma'am,
virtual
you are muted.
Uh, yeah. So this table is showing the difference between the public cloud and the private cloud. Basically, in case of your virtualized resources, in case of public cloud, it is publicly shared, whereas in case of private cloud, these are privately shared. Also, only the members of a particular organization can access the resources. However, in case of public, anyone can share. After that, the customer type of public cloud is multiple, and in case of private, it's limited. Then connectivity, it's over the internet in case of public cloud. However, in case of private cloud, it's over the internet, that is the private network only. Next one is security. In case of public cloud is very low, however in case of private cloud it's high. Then the other type of cloud, the next type of cloud is community cloud. So in case of community cloud, it is shared setup between several organizations having common concern. For example, security, compliance,
हम
justice.
हाइब्रिड को एक बार और एक्सप्लेन कर सकते हैं?
Yeah, hybrid cloud basically it is managed by more than one organization. So those organization can either be public, private, or it can be community. Basically combination of different kinds of cloud. Okay, so all the facilities which can either be provided by different kind of public clouds or private cloud, these can be provided by hybrid cloud. The basic difference is that it is managed by different organizations. Yeah, then distributed cloud. So it is a collection of scattered set of computing devices in different locations, however which are these devices are connected to a single network. So it can be of two types. First one is public resource computing and volunteer cloud. So basically in case of distributed cloud, various servers are integrated through a common network, and these servers are going to provide services to the end users. Then multi-cloud. So multiple cloud computing services are offered by a single heterogeneous architecture. In case of your multi-cloud, it provides increased fault tolerance and flexibility. Then intercloud. Intercloud means the interaction between different kinds of clouds which are available. So it is cloud of clouds basically. So it supports the interoperability between different cloud service provider. So yeah, I have already told that nowadays there is a concept of sky computing. Sky computing is basically providing the interoperability between different kind of clouds. So the please mute yourself. So basically with the help of this sky computing concept, the end users are going to access the services from different service provider, irrespective of getting to know that from where we are exactly getting the service. Then next is comparison between different deployment models. So uh, if it is on premise and there is dedicated access, it means it is a private cloud. And if it is dedicated access and off premise, then it means it is a hosted private cloud. Then shared access. So if it is shared access and on premise, it means community cloud. And if it is shared access and off premise, it is public cloud. Then service models. So there are three kinds of service models. First one is platform as a service, second is software as a service, and third one is infrastructure as a service. So platform as a service is responsible for providing security, identity, integration workflow, application grid, UI services, database grid. However, your software as a service is responsible for providing various kinds of software to the end user for packaging, for configuration, deployment, scaling, lifecycle management, utilization, and user management. And third one is infrastructure as a service. So it is responsible for providing various kind of virtual machines with the help of which you can perform your task which you want to perform. So infrastructure as a service. Shared access, then in case of your on-premise, community cloud can be used, and in case of your off-premise, public cloud can be used. Now the service models. So there are three types of service models. First one is your PaaS, that is your platform as a service. Second one is your software as a service, and third one is your infrastructure as a service. So in case of your platform as a service, particular platform is provided to the user in order to perform the application, right? In case of your infrastructure as service, infrastructure or different hardwares are provided to the users. And in case of your software as a service, complete softwares are provided, complete applications are provided to the end users. So infrastructure as a service, infrastructure as a service, which is also abbreviated as IaaS, contains the basic building blocks for cloud IT and typically provide access to networking features, computers, and data storage space. So it provides on-demand delivery of computing infrastructure. It also provides server compute, machines, storage, network, and operating system. So basically the infrastructure is provided in case of your infrastructure as a service. Now the working methodology. So the user rents the server, software, and data center space or the network equipment to the end user. So on the basis of the time for which a particular infrastructure is used, the users are charged accordingly. So cloud service providers offers a resource management and outsource service on demand model. Now why infrastructure as a service is required? So for new businesses can operate without investing on computer hardware. So whenever you are going to set up new business, you need different infrastructures, right? So with the help of infrastructure as a service, you don't have to invest on purchasing different hardware. You can use infrastructure as a service and use the resources which are available in the resource pool. Second is scalable for rapidly growing businesses. Third is it is suitable for serving fluctuating computing demands. For example, your Flipkart, Amazon during festival sales. So there is a cloud computing is scalable basically. So it can handle the fluctuating computing demands. Then it is suitable for new business model trials, and it also helps in minimizing the capital expense. Now the characteristics of infrastructure as a service. So first one is your manageability and interoperability. So what does this manageability and interoperability mean? So clients have total control of the virtualized infrastructure resources. Pre-configured facility for allocation of virtualized resources is there. The virtualized resources are to be monitored for their running status. The usage and billing system records the use of infrastructure resources and accordingly circulate payments. The next is your availability and reliability. So the stored data can be retrieved at any time without failure. The clients should be able to access the computational resources without any failure. There is uninterrupted facility for computation and communication. The third characteristics is accessibility and portability. So there is a facility for clients to ease the various tasks, for example, control, manage and access infrastructure resources. To facilitate easy reallocation and duplication of allocated infrastructure resources, infrastructure as service can be used. Then next is performance and optimization. So there is high utilization of physical resources among different clients. To enable high computing power with a large pool of physical resources, using parallel processing is there. Then to optimize the deployment of physical resources by deploying dynamic configuration of virtual infrastructure resources also there. Now the categories of infrastructure as a service. So infrastructure as a service can be obtained as first one is your public cloud. So there is shared infrastructure resources available for self-service basis. Second one is your private cloud. Private infrastructure resources are there and they can be accessed on the basis of access control. So the users who have the access for particular resources can only access these resources. Then third one is your hybrid cloud. So it is a blend of both public and private. Now the challenges and limitations of infrastructure as a service. So first is sometimes the regulatory approval does not allow outsourcing the storage and processing of sensitive data. Second one is network latency may degrade the level of expected performance. Third one is users may require automated decision making of job scheduling to available resources. Then seamless scaling of services independent of traffic variation is there. Developers have to focus on low level system details. Now the next one is your platform as a service. So platform as a service removes the need for organization to manage the underlying infrastructure, that is usually your hardware and operating system, and allow you to focus on the deployment and management of your applications. So this is the definition given by Amazon. Platform as a service provides the platform which allows developer to create applications which can be offered as service by internet. It simplifies the application development and deploy, providing the Cloudware feature. Platform as a service is an application middleware offered as a service to the developers. It provides abstraction and security for deployed applications. Platform as a service also facilitates development and managing applications without the complexity of maintaining the underlying infrastructure. It allows customers to rent virtualized servers and associated services. It also provides elastic scaling of users' deployed applications. Now the features of platform as a service. So first one is your operating system. Second is server side scripting environment. Then database management system is there. Server software is there. You can provide support to the end user. Storage is there. Network access tool for design and development is there. And then hosting of different applications is there in your platform as a service. Uh, then platform as a service working model. So basically it allows user to create software applications using offered tools. Second is it provides pre-configured features that customers can subscribe. It supports available for managing the infrastructure and application for customers. uh, serve In case of your platform as a service, the services are regularly updated with new features. Then the business advantages. uh, fac- uh, it provide facility for accessing key middleware services without worrying about the underlying complexities of managing individual hardware and software element. It There is an ease of access for the development and deployment tools. There is also a freedom from managing development and deployment tools individually. Now next one is your software as a service. So software as a service provides you with a completed product that is run and managed by service providers. In most cases, people referring to software as a service are referring to the end user application. So this is the definition which is given by Amazon. In case of software as a service is a simplified model of software delivery over network. Operation, maintenance and technical support is provided by the service provider in case of your software as a service. It typically offered by web browser working as a thin client. It supports fully pay as you go model. So basically whatever you will use, you have to pay for that. Remote access of software by internet where web browser act as a thin client. Then a facility for access and control of commercial software by internet is there. Then multi-tenant application delivery in one to many model is there. Now this is the this table is showing the difference between your traditional software and software as a service. So in case of your traditional software, customer install, manage and maintain the software. However, in case of your software as a service, customer uses the particular software over the internet. So traditional software runs on individual organization on dedicated instantiation. However, in case of your software as a service, it runs on multiple customers simultaneously. Then in case of your traditional software, cross-platform support is required. However, in case of your software as a service, no concern for cross platform service support is there. Then next one is your less frequent version updates and purchased separately in case of your traditional software. However, in case of your software as a service, more frequent updates for enhanced user satisfaction should be there. Then in case of your traditional software, separate cost incurred for upgrades. However, in case of your software as a service, no separate cost should be there. Then next is your traditional software. It is vulnerable to software piracy. However, software as a service is less vulnerable to your software piracy. Now the architecture of your software as a service. So first one is your scalability. So in order to maximize the application concurrency, scalability should be there. To optimize the shared pool of resources such as threads and network connection should be there. Second one is your multi-tenancy. So important architectural shift from designing isolated single tenant application is there in case of your software as a service. It has the ability to accommodate users from multiple companies at the same time. So it also provides transparency to all the user and maximize the sharing of resources across the tenants while distinguishing users individual data. The next one is your configurability. So to facilitate the parallel allocation of single application on single server to several users, to customize the application of one customer will change the application for other customers as well. Then separate data space is there for different user in case of your software as a service. Now the limitations of your software as a service. So first one is your centralized control. So in case of your software as a service, there is a centralized control. So if that is one of the limitation. And then second one is your switching cost. Third one is your limited flexibility is there, and the fourth one is your data security and privacy. Now this is the this figure is showing the comparison of different service models. So basically in case of your in case of your traditional model, so all these things are maintained by users only. So application, data, runtime, middleware, operating system, virtualization, server, storage, networking, all these things are maintained or used by user only. However, in case of your infrastructure as a service, the service providers will provide the users with your virtualization, server, storage and networking. However, your user is going to maintain only application, data, runtime, middleware and operating system. In case of your platform as a service, the service provider will provide you the complete platform. For example, your runtime, middleware, operating system, virtualization, server, storage, networking, all these things are provided by the service provider only. The user only have to use their own application and data. And in case of your software as a service, complete software, that is your application, data, runtime, middleware, operating system, virtualization, server, storage, networking, all these things are provided only by your service provider. Now service management and security. So it deals with the world of cloud computing and service management, ensuring optimal performance and efficiency in on-demand virtual environments. It aims to provide equal importance to desired outcome of customers. The management of services at no cost and risk is required in case of your cloud computing. Then the objectives are, in order to provide standard services, clear and complete description of services should be there. Usage and usage monitoring and billing should be proper. So for the particular amount of time you are going to access the service, only for that amount of time the user should have to pay the bill. Next is high availability of networks and connectivity should be there. Then the ease of access, so the resources should be easily accessible to the end users. Portals for service selection should be there. Rapid fulfillment and decommissioning of resources should be there. Then service guarantees should be there. Secure computing and storage should be there in case of your cloud. Now the service level agreement. So service level agreement is a document which defines the non-functional requirements expected from the service providers. It basically provides a roadmap with clearly defined deliverables. It describes the quality, utility and warranty of services expected by the users from the service providers. Now the accounting and billing. So service accounting, so it aims to obtain resources usage information typically in the form of records. It depends upon the infrastructure and service monitoring as usage information is obtained from the metric measurement. The next one is your billing. So the service provider calculates the billing information using your accounting records, resource prices and billing rules. So basically your service providers are going to use accounting records, resource prices and billing rules in order to calculate the bill of a particular service which is used by the user. Now comparing the scaling hardware for your traditional versus your cloud computing. Now in case of your traditional data center, heterogeneous hardwares are available, network computing is there and remote servers are there. However, these are available in on-premises. However, in case of your cloud computing, all the infrastructure is present at off-premises. Virtual hosting solution is there, and heterogeneous hardware, software and networks are available on the cloud. These are not available at the user's end. And then the major differences include resilience and elasticity. So basically in case of your cloud computing, resilience and elasticity is more as compared to your traditional data center. There is more flexibility and scalability, more automation, running cost is less, and there is more security in case of your cloud computing. Now managing the data in cloud. So first we will discuss the steps in evaluating the database manager. So it defines the type of application that will be served, like data asset protection, business intelligence and e-commerce. It determines how suitable these apps are for public and private cloud. It also describes the factors affecting the easy development process. Then next is demand of cloud database management system. So it should be efficient, fault tolerant, adaptive to heterogeneity, and the operational comfort on encrypted data should be there, and it should be capable of interfacing with other products and solutions. Next one is database as a service. So basically your Microsoft Azure SQL database can be provided as a database as a service. Then next one is your Amazon Web Services, Dynamo database, relational database services are there. Then Google Cloud SQL is there, Google App Engine Data Store is there, ClearDB is there, database.com is there. So all these databases can be provided to the end user as your database as a service. Now cloud security. So the basic problem is user loses the control of information available on the public cloud. So basically there is a need of security. So in case of your cloud computing, because there are various security concerns that are present. So first one is your loss of data can be there, account seizing is the one of the major issue that can be there, service traffic hindrance can be there, then vulnerable APIs can be there. So the solution for this is there should be protection from theft, leakage and deletion by providing secure policies. Now the first one that we will discuss is infrastructure security. So infrastructure security means the security of cloud infrastructure must be implicitly assured in case of your cloud computing for both your public as well as your private cloud, and for all the services, that is your service as software as a service, platform as a service and infrastructure as a service. Then building levels for viewing, evaluating and executing infrastructure security are network level security, host level security, and application level security. So first of all, we will discuss about network level security. So it should be in case of your public cloud, small change severely affects the network topology. Then there should be proper access control for using the resources, which can be achieved so we were discussing about network level security. So in case of your public cloud, small change severely affects the network topology, and there should be proper access control for using the resources, which can be achieved by confidentiality and integrity of data in transit to and from the cloud service provider. There should be availability of internet resources correctly to genuine user from the cloud service providers. Now next is your host level security. So host level we will discuss the host level security at a platform as a service and software as a service level. So it hides the host operating system from the end users, and the security responsibilities are transferred to the cloud service providers. Host security at infrastructure as a service level, the primary objective is to secure the allocated host. The example of the threat in case of host secure at infrastructure as a service level is blue pill attack and hypervisor. Then application level security. So both CSP and customers are responsible for security at your application level. Now the objective of now we will discuss about data security. So basically the objectives of data security is to ensure confidentiality, integrity and availability, and the solution available in order to provide these features are: first one is your identity management. So all the users who are going to access the resources, their identity should be managed properly, and the services should be given or the data should be given to the authorized user only. Encryption of data should be there, and access control should be there. Now the aspects of data security. So all the data, for example, the data in your transit, data at rest, data including multi-tenancy, data lineage, data remnants, and data provenance. So these are the various aspects of your data security. So all these different types of data should be secured. Now identity and access management. So a branch of cloud security that allows the legitimate person to retrieve the legitimate resources at the legitimate time for the legitimate reason. The user identifies and access permissions are instigated, caught and administrated and recorded by IAM in case then authentication, authorization and evaluation of all the users are done according to the terms and conditions and the roles of the users. Now the features of IAM, that is your identity and access management. So it is a single access control interface. It increases security. Access control over resource level is provided by IAM. Then there is an improvement of operational efficiency. The organizations attain access control and operational security using IAM. It also results in the improvement of regulatory compliance management. Now the access control. So access control layers in cloud include cloud access, server access, service access, database access, virtual machine access, access to objects within the virtual machine, and the management of these layers depend upon the provider or the consumers based on the deployment model. Now the trust and reputation. So what do you mean by trust? So independent expectancy between two entities for any specific context at a given time is trust, and reputation is the belief of entities standing by the community. So these two concepts are needed by the customer in order to select the appropriate cloud provider. So different modes of trust establishment include accomplishment of your service level agreement. Second is your application of audit standards, measuring and ratings, and questionnaires for self assessment. So basically users also decide that which service provider to use on the basis of self assessment, that which particular service provider is suitable for him or her. And then next is your risk assessment. So it is defined as the categorization of different assessment methodology. Formal versus informal procedures are there. Then qualitative and quantitative techniques are also there. Consequence versus cause analysis is there, and inductive versus deductive techniques are also there for doing your risk assessment. So basically different categories are there, and these are further 4 categories. First one is your formal informal, second quantitative qualitative, consequence and cause versus, and inductive and deductive. Now authentication in cloud computing. So user authentication. So user authentication process between new user and service provider. So service provider are going to authenticate the users who are going to access the services from that particular service provider. So during the authentication, the properties and safety of a process can be invaded by the attacker, causing the severe damages. So user authentication is done at your platform as a service layer, and the consequences threat to authentication process can lead to divulge of confidential data to fake user. Now the cloud simulations. So simulation tools provide reliable, scalable and repeatable environment for performance evaluation. The simulator facilitate pre-deployment test of services. As the demand of cloud computing is growing every day, the simulators and techniques are needed to be studied. So the cloud simulators allow customers to evaluate the services. Testing at it also allows testing at no cost, enable repeatable evaluation, control the environment, pre-detection of issues affecting the performance can be done. Then the design of countermeasures can be done with the help of cloud simulators. Now the different cloud simulators that are available are Cloud Sim, Cloud Analyst, Green Cloud, Icon Cloud, Ground Sim, DC Sim. Now the questions, but before starting the question we will take a break of 2 to 3 minutes, and after that we will start.